Have you ever wondered how you can make $1 million? This infinite sum may be the solution. The Riemann zeta function was explored by Bernhard Riemann and typically takes the form of a Dirichlet series and is defined for complex values of S. The function has strong connections to quantum mechanics and prime number theory, particularly due to the locations of zeta's non-trivial zeros. Though the domain S is considered to be a complex number, the convergence of the zeta function actually depends on the real part of S. The zeta function converges absolutely for the real part of S larger than 1. When the real part of S is equal to 1, the zeta function diverges due to a simple pole at this location. We can also recognize that when the real part of S is equal to 1, we form the harmonic series, which is a known divergent series. One of Riemann's main achievements in his paper was the derivation of the functional equation of zeta. Riemann derived the functional equation to define zeta for all values of S. This form is symmetrical and remains unchanged when S is substituted by 1 minus S and vice versa. The zeta function at negative integer values of S can be expressed by rearranging the functional equation in the Bernoulli numbers. It can be deduced that zeta possesses trivial zeros when the real value of S is negative and even. This leaves the pot of gold that is the critical region. The Riemann hypothesis states that the non-trivial zeros of zeta have a real part equal to 1/2. This has been tested and verified for the first 10 trillion solutions, but requires a proof. The Riemann hypothesis is one of the 7 Millennium Prize problems from the Clay Mathematics Institute, each with a $1 million prize for a correct solution. So, do you think you have what it takes to solve them? One of the most significant applications of the Riemann zeta function is the prime number theorem. The prime number theorem estimates the distribution of prime numbers by relating the prime counting function pi x to the logarithmic integral function x. The zeta function can be connected to the prime counting function via the identity involving the log of zeta and the Riemann prime counting function j, x. Freeman-Dyson noticed that Montgomery's pair correlation conjecture and the Gaussian unitary ensemble, GUE, of random matrix theory both possess the same pair correlation function. This suggests that the energy levels of large quantum systems mirror the distribution of zeta zeros. This implies that the zeros of zeta are not randomly distributed and in fact experience repulsion, where two nearby energy levels are less likely to occur close together in comparison to a purely random distribution. This is with the assumption that the Riemann hypothesis is true. Thank you for listening.
Created using Powtoon.